All right, welcome back to TalkTensors. Today we're going to be taking a look at a paper all about artifact detection.
Yeah, artifacts.
You know CT.
So OCT, for those of you who maybe aren't familiar, it's a really cool imaging technique that's used in cardiology, and it's called Optical Coherence Tomography.
Yeah.
But we're not going to be talking about OCT in general. We're going to be talking about artifacts, which are these little, well, sometimes they're not so little, these things that get in the way of having nice, clean OCT images. And so the paper we're looking at today uses some really cool machine learning to try to detect and even grade the severity of these artifacts.
Yeah, and this is actually a really big problem because OCT is one of those technologies where it's really important to get a good, clear image. I mean, it's like when you're trying to take a photo and there's like smudges on the lens.
Exactly.
You just can't see what's going on. And in this case, it's not like smudges on a lens. It's like little bits of blood or gas bubbles that are floating around in the artery while they're trying to take this picture.
Yeah, so you can imagine you're a cardiologist and you're trying to look at the inside of a coronary artery to see if there's any blockages or plaque buildup.
Right.
And suddenly there's this big shatter in the image.
Right.
You know, it could be a real problem or it could just be a harmless artifact.
And it's really hard to tell the difference.
Yeah, exactly.
And so that's where this paper comes in. They've developed this system that can actually automatically tell you, hey, this is just an artifact, don't worry about it. Or, hey, this looks like a serious artifact, you might need to retake the image or take a closer look.
Yeah, and this is a huge step forward because right now cardiologists have to kind of eyeball these images and try to decide whether an artifact is real or not.
Right.
And that's obviously very subjective and can lead to errors.
Yeah, human error.
Yeah.
And we all know that computers are much better at these kinds of things than humans are.
Exactly.
So the fact that they've been able to develop an AI system that can do this automatically is really exciting.
Yeah, and it's not just about making things easier for cardiologists, it's also about patient safety.
Yeah.
Because if you miss a real problem because of an artifact, that can have serious consequences.
Absolutely.
So this technology has the potential to really improve patient care.
So to jump into this a little bit deeper, you know, I know we've talked about OCT before on the show, but just to remind everyone again, what exactly is OCT and how does it work?
So OCT, like I said, it stands for Optical Coherence Tomography, and it's a little bit like ultrasound, but instead of using sound waves, it uses light waves.
Okay.
So they basically shine this infrared light into the artery,
Okay.
and then they measure how long it takes for the light to bounce back.
Okay.
And based on that, they can create a really detailed three-dimensional image of the artery wall.
So it's almost like a radar kind of system.
Yeah, it's similar to that, except it's using light instead of radio waves.
Gotcha. Okay.
And the resolution of OCT is really incredible. You know, we're talking about being able to see features that are just a few microns across.
Wow.
So you can really get a good sense of the structure of the plaque, the thickness of the artery wall, and all sorts of other important details.
And you were saying this is like kind of the next generation beyond just like an X-ray image of an artery.
So X-ray angiography, that's been around for a long time, and it's still a very useful tool. But it only gives you a two-dimensional shadow image of the arteries.
Okay.
So you can see where there are blockages.
Right.
But you can't really see the details of the artery wall.
Right.
And that's why OCT is so valuable, because it gives you that extra level of detail.
Gotcha. Okay.
So it's really revolutionized the way we diagnose and treat coronary artery disease.
So then kind of going back to these artifacts.
Yeah.
What are the main types of artifacts that we see in OCT?
Well, there are a few different types, but the ones that this paper is focused on are what we call attenuation artifacts. Okay.
And these are caused by things like blood residue or gas bubbles that get in the way of the light beam.
Okay.
So basically they cast a shadow in the image.
Okay.
And that shadow can make it really hard to see what's going on underneath. There are other types of artifacts like guide wire artifacts, which are caused by the wire that they use to insert the OCT catheter.
Right.
But this paper is specifically looking at these attenuation artifacts, which are a particularly challenging problem.
And so before these sort of AI systems came about, how are people dealing with these artifacts?
Well, pretty much just by eyeballing them.
Really?
Yeah, you know, they'd look at the image and they'd say, okay, that looks like an artifact.
Yeah, right.
Or that looks like a real problem.
Right.
But it was very subjective.
Yeah.
And there was a lot of room for error.
Right. Right.
There were some basic signal processing techniques that they could use to try to clean up the images, but those weren't always very effective.
And they could sometimes introduce new artifacts of their own.
Oh, wow.
So yeah, it's definitely a big problem.
So it sounds like this machine learning solution is a real game changer.
Oh yeah, absolutely.
So can you tell us a little bit about how this AI system works?
Sure. So the system that they developed in this paper is called ARKNet.
Okay.
And it's a type of deep learning model called a convolutional neural network.
Right.
Which is really good at analyzing images.
Yeah, we've talked about CNNs before. They're kind of the go-to for any kind of image analysis.
Exactly.
Right. So this ARKNet, it looks at the OCT image and it tries to identify the artifacts.
Right.
So how does it actually do that?
Well, it does it in a really clever way. So OCT images are basically made up of these things called A-lines.
Right.
Which are like these radial scans of light.
Okay.
So they start at the center of the artery and they go out to the edge.
Okay.
And each A-line represents a different depth in the artery wall.
Gotcha.
So what ARKNet does is it looks at each individual A-line.
Okay.
And it tries to decide whether that A-line is affected by an artifact or not.
Okay.
And if it is affected by an artifact, it also tries to classify the severity of the artifact.
Oh, wow. So it actually puts like a grade on it.
Yeah, exactly.
Like a mild artifact or a severe artifact.
Right.
Okay.
And so it does this by using two different views of the OCT image.
Okay.
So the first view is just the standard Cartesian view.
Okay.
Which is like the normal way that we look at images.
Right.
But then they also use this polar transformation.
What is a polar transformation?
So imagine you take the circular OCT image.
Okay.
And you unroll it into a rectangle.
Okay.
So now all of those radial A-lines are arranged in vertical columns.
Oh, I see.
And this polar view is really helpful for identifying artifacts because the shadows that the artifacts cast are now all aligned in the same direction.
Oh, that makes sense.
So it's much easier for the AI to pick them out.
Gotcha.
So ARKNet has two separate branches.
Okay.
One for the Cartesian view and one for the polar view.
Okay.
And then it combines the information from those two branches to make its predictions.
So it's almost like having two different experts looking at the same image.
Yeah, exactly.
And then they're like comparing notes and coming up with a consensus.
Right.
That's really cool.
And the results that they got were really impressive.
So tell me about the results then.
Well, they tested their system on a data set of OCT images from 75 patients.
Okay.
And they found that it was able to detect artifacts with really high accuracy.
Right.
In fact, for severe artifacts, it had an F-score of 0.94.
Wow.
Which is really good.
Yeah, that sounds pretty good.
That means it's correctly identifying almost all of the severe artifacts.
Yeah.
And for mild artifacts, it had an F-score of 0.77.
Okay.
Which is still pretty good, but it shows that those mild artifacts are a little bit more challenging to detect.
Yeah, it makes sense. They're a little bit more subtle, right?
Yeah.
But it's going to be harder for the AI to pick them out. But still, I mean, 0.77 is pretty good.
Yeah. And what's really impressive is that this system can do all of this in just a few seconds.
Really?
Yeah. So it has the potential to be used in real time during OCT procedures.
So as the doctor is taking the image,
yeah,
they could actually see this information pop up on the screen.
Exactly.
Wow, that's really cool.
Yeah, it's really exciting.
So they really did a good job with this.
Yeah, and they also compared their system to some other methods that have been developed for artifact detection.
Okay.
And they found that their system outperformed all of the other methods.
Oh, wow.
So it's really state of the art.
So it sounds like this is a big step forward for the field.
Yeah, it really is. You know, it has the potential to make OCT imaging more accurate, more efficient, and ultimately safer for patients.
Absolutely.
So it's a really exciting development.
Yeah, and I imagine this kind of technology could be applied to other types of medical imaging as well.
Yeah, absolutely.
Where artifacts are a problem.
You know, artifacts are a problem in pretty much every type of medical imaging.
Right.
So this kind of AI-based approach could be really valuable for a wide range of applications.
So this is maybe like the start of a new wave of medical imaging analysis.
Yeah, I think so.
That's really cool.
You know, we're seeing more and more applications of AI in medicine.
Right.
And this is just one example of how it can be used to improve patient care.
So now that we have this technology, this ARKNet system, what are some of the next steps? Like, where do we go from here?
Well, I think one of the most exciting directions for future research is to incorporate temporal information into the artifact detection process.
Okay.
So right now, the system is basically just looking at each frame of the OCT image in isolation.
Right.
But OCT is actually a dynamic imaging technique. You know, they're constantly acquiring new images as they move the catheter through the artery.
Okay.
So there's a lot of temporal information that's being captured. And I think if we can find a way to incorporate that information into the AI system, it could potentially make the artifact detection even more accurate.
So like looking at the image over time.
Yeah, exactly.
So not just a single snapshot, but like a whole video essentially.
Right, yeah.
Okay. And so how would we actually go about doing that?
Well, there are a few different approaches that we could take.
Right.
One option would be to use a recurrent neural network, or RNN, which is a type of neural network that's specifically designed for analyzing sequential data.
Right.
So we could feed the entire sequence of OCT frames into an RNN.
Okay.
And it could learn to identify patterns in how the artifacts appear and disappear over time.
Right.
For example, a small gas bubble might just create a fleeting artifact that only lasts for a few frames.
Right.
Whereas a blood clot might create a more persistent artifact that lasts for many frames.
Okay.
So by looking at the temporal evolution of the artifacts, the AI could potentially make more accurate predictions about whether an artifact is real or not.
That makes sense.
Another approach that we could take would be to use a three-dimensional CNN.
Okay.
So instead of just looking at each frame individually, we could stack multiple frames together and treat that as a three-dimensional volume.
Yeah, okay.
And then we could train a CNN to analyze that volume.
Okay.
And that would allow the CNN to see the artifacts in context.
Right.
And to understand how they're changing over time.
So it's almost like giving the AI a deeper understanding of the anatomy of the artery.
Yeah, exactly.
And how the artifacts are affecting that anatomy.
Right.
Okay, so this is a really cool area for future research.
Yeah, I think it's a really promising direction.
And it could potentially lead to even more accurate and reliable artifact detection.
Absolutely.
Well, this has been a really fascinating deep dive.
Yeah, it has.
We've learned a lot about OCT imaging artifacts.
Yeah.
And how AI can be used to detect them. So thank you so much for joining me today.
It's been a pleasure.
And for all of you listening out there, if you want to learn more about this research, we'll have a link to the paper in the show notes.
And be sure to check back next time for another deep dive into the world of machine learning.
Okay, well, until then, keep on learning.
And keep on tensoring.
All right, bye.
Bye.